Hello everyone. Today we are going to discuss about machine learning. So in our previous class, we have discussed about brief history of machine learning. In this class, we are going to discuss about the definition of machine learning and the different types of machine learning. So from this class, we are going to learn about the definition of machine learning and the different types of machine learning, such as supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So, according to Tom Mitchell, what is machine learning? So, a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improved with experience E. So now, what is this experience, class of task, performance measure, etc.? So let's take an example. Whenever a child learns something like alphabets or anything like that, so in that case, the task is to learn the alphabet. Okay, so the task T is learning those alphabets A, B, C, D, E. And what are the experience? Experience is those letters. So A, B, C, D, E, these are the experience. And what will be the performance measure? So if a child can recognize a letter as A or B or C, then she or he is learning. So performance measure is any kind of matrix which actually measures the performance. Okay, so now in terms of machine learning, so a computer program is said to learn from experience E. That means any kind of data, previously collected data, with respect to some class of task T, any kind of task, learning task. We are going to discuss it in our next slide. And performance measure. So there are different types of metric to measure the performance of a machine learning algorithm. So when we are going to say that the program is learning, when its performance at that task as measured by P improved with data or experience. Okay. So now from the previous slide, we can generate some components of learning problem like task T. I have already told you the task is actually which the machine is going to learn. So the behavior of the task that is being improved. So there are different kinds of tasks like classification, clustering, acting in an environment. These are the tasks. Now, what is data, which is actually denoted by E? The experiences that are being used to improve performance in the task. So labeled data, unlabeled data, unknown situation in an environment, these are actually called as data. Next one is measure of improvement. So example is increasing accuracy in prediction, new skill that were represent initially or improved speed, etc. So now we are going to talk about different types of learning. So there are basically three major types of learning: supervised learning, unsupervised learning, and reinforcement learning. And there is also another kind of learning which is semi-supervised learning. Okay, so supervised learning, what is supervised learning? Supervised learning is basically to learn an input-output map. So the machine is given input feature along with the output level, and from that it is going to learn the mapping or the function which actually maps input to output. So regression and classification are the examples of supervised learning. Next one is unsupervised learning. So in case of unsupervised learning, there is no label data or output. So discovering the patterns in the data is the major focus of unsupervised learning, and the example of different unsupervised learning algorithm are clustering, association, sometimes dimensionality reduction is also considered as unsupervised learning. And in case of basically reinforcement learning is learning control. So in this right side diagram or chart, you can see that supervised learning is basically task driven learning, and its aim is to predict next value. In case of unsupervised learning, this is basically data driven, and the aim of unsupervised learning is basically to identify different clusters or summarize the data. And in case of reinforcement learning, the learning algorithm learns from its desirable acts or reward and mistakes and punishment. So in this slide, we are going to discuss it a little bit in detail. So in case of supervised learning, the training examples are represented as capital X and Y, though capital X is the input feature vector. There may be a single feature or multiple features, and Y is the level of output. So the training example consists the input feature vector and the output level. And from this training example, machine is actually learns a mapping which actually maps input feature vector to output level. And in case of so the aim of supervised learning is to give an observation X which is unknown to the machine, and what is the best level for Y, that is our prediction. In case of unsupervised learning, there is no level data, only the input feature vector, and from that input feature vector, the machine will learn to cluster or grouping the data, and given a set of X's, it's actually cluster or summarize them. In case of reinforcement learning basically determines what to do based on reward and punishment. So now we're going to talk about supervised learning. Supervised learning is when the model is getting trained on label data set. I have already told you. So what is basically label data set mean? So in this case, this image is of an apple. So now we are going to make the machine learn to recognize apple. So we will provide the machine with the different types of apple and the label. So this is the input feature vector and this is the apple. So both are going to provide it to the learning algorithm, and from that learning algorithm, the machine automatically learns what kind of feature vector will be there if we call that object as an apple. So it will learn the behavior or characteristics of apple, and the when it learns the characteristics of apple and it successfully recognize learn to successfully recognize an apple, we call that as the model. Now we actually shows an apple which the machine has not seen before, and if it perfectly recognize that it is an apple, then we say that machine has learned to recognize apple. So we can put it in a schematic diagram. So this X and Y, this is the training example, input feature vector and output level. And with this training example, we actually train the learning algorithm. And when it learns to recognize or from the training example, then the mapping is actually the model. Now we actually give the model a new input X and it must predict the Y value. We can also present it like this. So this is the training part. In that case, we give the learning algorithm training sets, and from that training set, it learns a function or mapping or hypothesis. And after training, so this period is called training, and this period is called testing, when we actually give the machine unknown X and it should predict the Y. So these are the popular examples of supervised learning. One is house price prediction and another is small male classification. So in this case, in case of house price prediction, the Y is continuous. So if I give the area of the house, the machine learning algorithm must predict the price of the house, and in this case y is continuous. If I just give an email, it must tell me is it a spam or non-spam. So this problem is called regression and this problem is called classification. Now we are going to discuss about unsupervised learning. So unsupervised learning is when the model is getting trained on a unlabeled data set. That means we only have the input data, but we don't have any label of those input data. So we actually give the input data to the learning algorithm, and it will discover some pattern, or it will group depending on different behavior or different characteristics of the data. And if we just give an random data which the running algorithm does not think before, it should group that data in a proper class or cluster. So in this case, we can see it in schematic diagram. So these are the input, and we can see that there is no label, and from the data learning algorithm will learn to cluster those data. So this is a pizza house problem, a popular problem. It actually means that a pizza company want to open a branch of their next pizza parlor. So which place will be the best? So this is the clustering problem, and the multi-cluster analysis or association problem. In this case, if a person buys something, then is there any association of in these items? Now, reinforcement learning. It features an algorithm that improves upon itself and learns from new situations using a trial and error method. Favorable outputs are encouraged or reinforced, and non-favorable outputs are discouraged or punished. If we want to understand about reinforcement learning, let's take an example. Like, I am in an unknown island. I don't know what to do, what to eat, and where to go. So I am hungry and I want to have some food. So I just plucked a fruit from a tree and I ate it. So and I feel that it tastes bitter. So I just throw it out. Next time, if again I am hungry and I just choose another plant and I have some food from there, and it tastes very good. So so the first one was bitter taste and the second was one good taste. So next time, whenever I will be hungry, I will choose that fruit which tastes good. So similarly, favorable outputs mean which output we want, and non-favorable means the mistakes which we don't want. So a machine, in case of reinforcement learning, learns from trial and error method. Okay, it actually learns from new situation, and if the output is favorable, then it reinforces. That means it learns that I can do it again, and non-favorable outputs mean it make mistakes and learn that it should not do it again. Okay, so this is a puzzle problem. So this robot has to go in this destination, and there is a hole, there is fire, and there are different blocks. So if it actually goes to the right and then right, then left, and right, then it will actually reach to the destination. But if it takes an wrong step and go into this step, then it will never reach to the destination. So this is an a good example of reinforcement learning. So this is a diagram of reinforcement learning. In this case, agent take an action to the environment, and if it rewards, then it again take that action. And whenever the agent takes any action, the environment also changes to different state. So if the agent take a favorable state, then it is rewarded. That means it can do it again. But if it makes mistake, then it punished, and it learned that it should not do it again. Now, semi-supervised learning. Semi-supervised learning is an approach to machine learning that combines a small amount of labeled data with a large amount unlabeled data. So it is a mixture of labeled and unlabeled data, and the unlabeled data is much more than the labeled data. So unlabeled data, when used in conjunction with a small amount of labeled data, it can produce considerable improvement in learning accuracy. So here we can see that in figure A, this is the supervised learning, or this is label data. So this is the supervised learning, and here in this case, label and unlabeled data both are present. Some are labeled, some are unlabeled, and this is actually denotes as unsupervised learning. So in case of semi-supervised learning, few labeled data are given initially into the learning algorithm, and learning algorithm learns or trained on that few level data. Okay, and whatever it learns, upon that the unlabeled data are given, and from that unlabeled data it classifies it into the different class whatever he had learned from the label data. And that labeling, that classification or that prediction is actually considered as the label of the unlabeled data. And next time those previously labeled data and now the newly labeled data are both given to the machine so that it can learn again from that data. That is called retraining the classifier or retraining the machine learning algorithm. Okay, so where it is actually applied, a common example of an application of semi-supervised is a text document classifier. So this is the type of situation where semi-supervised learning is ideal because it would be nearly impossible to find a large amount of labeled text documents. So what we have learned in our today's class, so we have learned about the definition of machine learning, and we have also learned about different types of machine learning. So in case of supervised learning, labeled data is given, and in the learning algorithm learn input output map. In case of unsupervised learning, only the input data is given. There is no labeled data, and from that input data, learning algorithm learns to discover different patterns. In case of semi-supervised learning, label and unlabeled data, a mixture of label and unlabeled data is given. The labeled data is very less than the unlabeled data. And in case of reinforcement learning, this is a learning control algorithm basically. So in that case, the learning algorithm determines what to do with respect to reward and punishment. So with this, today's class is going to end. Thank you.